This lesson is triangle vocabulary, and I just realized I have not wrote the learning target, so give me a minute. Okay, here it is, magic. I can model and solve problems using triangle vocabulary. So these are vocabulary terms you may have already learned. They may be new to you, or we may just be reviewing, but these are things that are essential to our geometry unit that you need to know, understand, and be able to apply it to solve problems. So here we go. Okay, so these are vertical angles. All right, so vertical angles would be like 2 and 4. Those are vertical to each other. And 1 and 3. So if you'll notice, anytime you see like an X shape going on, angles that are across from each other are going to be vertical angles. So vertical angles are pairs of opposite angles made by intersecting lines. So the intersecting lines are the X's, and then the opposite angles are the ones right across from each other. Okay. So here's what you need to know about vertical angles. Vertical angles are always congruent, which means equal. Okay, so that's a vocabulary term. That's what you need to know about it. And then your example is going to be how you apply it. So if you'll look at these intersecting lines, these two angles right here are vertical. We know that vertical angles are congruent. So what we can do is we can take these two expressions, and if we know that they're equal, we can set them equal to each other, and we can find x. So I'm going to move the 10 to the opposite side by subtracting. So 50 equals 2x. And then I can get rid of that 2 by dividing. So x equals 25. So keep in mind, you need to understand the term. You need to know something about it, and then you need to be able to apply it to solve a problem. All right, so this one may be new. Segment addition postulate. Okay, so here's what this one means. This one says AB plus BC has to be equal to the entire length AC. So that's kind of like, well, duh, postulate, but it's a big deal. You need to know the name of it, you need to understand how to use it, and then you need to be able to apply it. So we have this segment. All right. AC, which is the entire thing, is 22. That's what that tells us. BC is x plus 14. That's what that one tells us. AB is x plus 10. And we are trying to find x. So here's what the segment addition postulate says. If I add AB to BC, then it should equal the entire length of AC. So all I have to do is add the two together and make it equal the entire thing. I'm going to get my like terms together. So this becomes 2x plus 24 equals 22. I was going to try to move the page up, but it is not working. Okay. So now I'm going to get my 24 to the other side. So I'm going to subtract it. I'm going to have to make that writing up here. I'm sorry. 2x equals negative 2. And then I'm going to solve x by dividing by 2. So x equals negative 1. So that is perfectly fine for x to be a negative, because if you actually plugged it back in, you would get that this side over here, AB, is 9. If you plug it into the other side, you would get this side is 13. And 9 plus 13 does, in fact, equal 22. So it makes sense. Okay. The next one is the angle addition postulate. All right, so I'm going to color code this one a little bit. This one says the measure of ABC, so A to B to C is this one. If I add it to the measure of CBD, that one's really ugly, sorry, it should equal the measure of ABD. So it should equal the measure of the big one. So it's just like the segment addition postulate, except you're not talking about segment, you're talking about an angle. Okay, so now we're going to use it and we're going to apply it to actually solve a problem. So the problem says the measure of GFN is right here, is equal to 4x plus 10. The measure of NFE, which is this one, is equal to 14x plus 3. And then the measure of GFE, the big one, is equal to 157. So here's what the postulate says I can do. I can take this angle, add it to the other little angle, and it should equal the big entire angle. Okay, so notice in this question, I'm not finding x, I'm finding the measure of angle NFE. So in order to do that, I'm going to get my like terms together. I'm going to get rid of the 13 by subtracting. And I'm going to get rid of the 18 by dividing. And I get x is equal to 8. Okay, that's just what x equals. I'm looking for NFE, which is the orange one. So what I'm going to do is I'm going to take x equals 8 and I'm going to plug it in right there. I'm going to replace the x with the number 8. And it's going to give me the measure of that angle. So 14 times 8 plus 13 is 125 degrees. That is my answer. Next, complementary angles. So this one you probably remember. Two angles are complementary when they add up to 90 degrees. So sometimes people do this in middle school. So a C, and then you can make it into a 9. That's how you remember it's 90 degrees. Alright, so these two angles are complementary. I know they're complementary because they have this little right angle symbol. Remember that equals 90 anytime you see that. So B plus 63 degrees has to give us 90 degrees. I can get B by itself by subtracting 63. So B has to be 27 degrees. So that's how you would use the definition of complementary to solve it. Alright, supplementary. Two angles are supplementary when they add up to 180 degrees. So you might have seen this in middle school. S for supplementary, you can make that into an 8. That's how you remember that supplementary is 180 degrees. So, all three of these angles have to add to give me 180 degrees. This one has the little angle symbol for right angle, which means it's 90. So 90 plus 40 plus 6x plus 2 has to add to give me 180 degrees. So I'm going to get my like terms together. I'm going to get rid of the 132 by subtracting. 6x equals... Sorry, I'm not trusting my brain this morning. Okay. That's a 48. And then I'm going to divide both sides by 6. So x equals 8. Okay, so that's how you would use supplementary angles to solve a problem. Alright, midpoint. Okay. So the midpoint, if you look on AC, would be directly in the middle, right here, and what it makes is two equal points. So let's call this B. It would make AB congruent to BC. That's what it is. Okay, so the midpoint is the middle between two endpoints. Alright, and I'm not going to use an example of that. Just know that the middle is directly in the middle of two endpoints. Alright, another word that you may not know, bisect. So bisect means to divide into two equal parts. So if I were going to take a line and I were going to bisect it, I would just cut it right in the middle and it would make the two sides equal to each other. So that's what the word bisect means. It means to cut into two equal parts. Alright, perpendicular bisector. All right, so there's two things going on. The word perpendicular means 90 degrees, and then bisect means two equal parts. All right, so a perpendicular bisector is a line segment perpendicular, meaning equal to 90, to and passing through the midpoint. So I'm going to draw a blue line, and it's going to be the perpendicular bisector of AB. If it's the perpendicular bisector, it makes a right angle, and it also cuts this line into two equal parts. So there's two things going on. It needs to be meeting the line at a 90-degree angle, and it needs to be slicing the line into two equal points. All right, median. So a median, usually when we talk about triangles, a median is a line segment joining a vertex. A vertex is like the top or a corner. And it joins the vertex to the midpoint of the opposite side, thus bisecting that side. So here's what it's doing. So here's the vertex. Here's the midpoint. They would connect. And this side over here would be bisected, which means it would be making two equal sides. So if you look at the picture, find x, if ET, which is this line right here, is 3x plus 2, and EM is 5x. Actually, we're just going to scratch this out, I'm sorry, because I'm getting ahead of myself. We're going to do this in a later unit. I just want you to understand the definition of midpoint. It's a line from the vertex to the midpoint, and it bisects the opposite side. We're going to talk about what actually happens later. Okay, so altitude. An altitude of a triangle is a line through a vertex, so one of the corners. Right. It's through the vertex and perpendicular. It should say to a line containing the base. Oh, no. It does say that. It's pretty good. Okay. So here's what it's talking about. So here's the vertex, and it would go straight down, making a 90-degree angle. It does not say it is bisecting that other side. It just has to be a line that is perpendicular with the base, and it has to go through the vertex. All right, let's do a few more. Angle bisector. So remember that word bisector means a line that splits something into two equal parts. So an angle bisector is a line that splits an angle into two equal parts. So if I were to draw an angle bisector, I would be splitting this angle into two equal parts. So both of these would be congruent to each other. So if you look at the example, we're going to find x if angle 2 is 4x plus 5, and angle 1 is 5x minus 2. So if we know that it is an angle bisector, that blue line, that means angle 2 and angle 1 have to be equal to each other. So I'm going to take those two expressions and set them equal to each other. I'm going to move the 4x over. You do not have to do it that way. You can do it another way and still get the same answer. And then I'm going to add 2. So x equals 7. That's how you would use that definition to solve a problem. All right, mid-segment. So we're going to learn more about a mid-segment later. I just want you to understand the vocabulary first. A mid-segment of a triangle is a segment connecting the midpoints, very important, of two sides of a triangle. This segment has two special properties. It is always parallel to the third side, and the length of the mid-segment is half the length of the third side. So here's what's happening. So because it's the midpoint, these two pieces would be congruent. This would also be a midpoint, so these two sides would be congruent. And then this would be your mid-segment. So these two lines are parallel. That's the symbol for parallel. And the mid-segment is half as long as the long side. So when you look at this, you know that this is the mid-segment, and this is your long side. So, you know that the mid-segment, is going to be twice as long as the long side. So I'm going to set it up like this. Then I'm going to distribute. Then I'm going to move my x over. Last I'm going to add 4. So x equals 7. The problem asked me to find RQ. RQ is the mixed segment. So I'm going to replace the x with a 7. And 7 minus 2 is 5. So 5 would be the answer. So these are vocabulary words that you need to know, understand, and be able to apply them. All right, so go try your assignment and let me know if you have any questions.